Okay, so this is problem number 10. It's asking to find the limit as theta approaches 0 of 1 minus cosine theta divided by theta. And the book also gives a hint. 1 minus cosine theta equals sine squared theta divided by 1 plus cosine theta if the absolute value of theta is less than pi. And so in the problem we see that theta is going to 0 and 0 is less than pi, so we can use this hint. And so the first step is substitute 1 minus cosine theta for sine squared theta over 1 plus cosine theta. So we write this as a limit as theta approaches 0 of sine squared theta divided by 1 plus cosine theta divided by theta. And now if we try to get a sine theta over theta as one of the fractions, we get the limit as theta approaches 0. We can rewrite this as sine theta over theta times sine theta divided by 1 plus cosine theta. And here we've just moved the 1 plus cosine theta into the denominator and split up the sine squared theta to two terms multiplied by each other. And so this we know is the same as saying the limit as theta approaches 0 of sine theta over theta times the limit as theta approaches 0 of sine theta over 1 plus cosine theta. And we can do this because of the product rule of the limits. We can put the limit on both sides. And now we know that the limit as theta approaches 0 of sine theta over theta is 1. And we multiply that with the limit of as theta approaches 0 of sine theta over 1 plus cosine theta. And so this is sine 0 divided by 1 plus cosine 0. And so sine of 0 is 0, and 1 plus cosine, this is 0, 1 plus the cosine 0 is 1 plus 1, so it's 0 over 2, which simplifies to 0. And notice we can just plug in numbers here because we don't have a 0 in the denominator, so we can evaluate this limit by plugging in 0 for theta. So our answer is 0.